Hello, everyone. I hope you're hearing me. So my name is Alan Aboudib, and I'm joining you here from Paris. I'm actually the NLP team lead at OpenMined, and today I'm going to talk to you about privacy-preserving NLP, and more precisely about Ciphertext, which is a library we are developing at the team to suggest a way for solving this problem. So actually, at any moment during my talk, you can ask me questions using the chat, the text chat. And if you are not hearing me or there's any technical problems, please write this down in the chat because I cannot hear you actually. So you need to tell me this using text. This talk will also be registered and it will be later released on YouTube. So it will be, you can use it as a personal reference for getting back to the tutorial details I will be presenting. So for today, you won't be manipulating any notebooks or like there will be no hands-on tutorial for you. I'm going to show a case. Of course, if you want, you can, but it's to avoid losing time, like installing the libraries and getting the things set up. We have only 1 hour, so let's begin. So let me find the slides. Yeah. So if you don't see the slides, please let me know in the chat. Yeah, so what is Ciphertext? So Ciphertext is an open source library. Currently, we are writing it in Python, and it is in the OpenMined, let's say, ecosystem. It leverages PySyf, so it uses the capabilities of PySyf to do encrypted training, federated learning, and communication across different workers. It uses these capabilities and builds a layer on top of this to enable NLP related capabilities. So as I said, it's a privacy preserving NLP library, and you will see what I'm talking about in a few seconds. So I'm developing this with a team here at OpenMined, and also with some other contributors that are currently contributing some code, and they are not part of the team, the core team, but they are part of the group of core contributors. So I will give special thanks to the team, namely Nilansh, who, like without him, it won't be possible actually to deliver this talk to you today, and Dramesh too, and Hersh, who contributed really heavily to this, like the Ciphertext 0.1.0 that is the subject of our talk. The release we are going to make available very soon, and that I'm going to present today, and also to Jatin, Sachin, and Antonio, who are also did amazing contribution to the core functionality of the library. So what is Ciphertext in a bit more detail? So I talked about privacy preserving NLP. So what is privacy preserving NLP? So two main capabilities actually that we need to have when we talk about privacy preserving NLP. And actually, let me share the screen, let me make it full screen so it's better. And please, as I told you, at each moment, if there's any technical problem, just let me know in the chat. Yeah, so when we talk about privacy preserving deep learning, NLP, we talk about the problem that when we have actually different workers and each worker has a text data set, and here I show it as string. As you know, we cannot just create a model, let's say a sentiment classifier, and feed it the text. if you work a little bit in deep learning, you might know actually that text should be converted first to a numerical format, let's say, numerical representation that we call embedding or word embeddings, or if we are talking about documents, group of words, document embeddings, which are basically tensors of like a group of words, like tensors that represent that group of words or those words. But in order to do that, the process is not trivial. So we first need to tokenize the string, and then we need to do some processing actually to create those embeddings. Or if we already have the embeddings, we need at least to tokenize the strings and then to use that, let's say, lookup table that we have of embeddings. We need to match these words to those vectors and to get those vectors as tensors that we can, after that, like encrypt and use for encrypted training. But notice there is non-trivial pre-processing that we need to apply on the plain text. And the problem is that if we don't have access to these texts because they are private data sets, we cannot look at them, we cannot actually manipulate them. So Ciphertext provides a way to send those tokenizers and all the processing components to operate remotely on those data sets without us or as data scientists seeing those text, the plain text. So we preserve the privacy. So if you want to do training of a model on different, like a group of data sets, like more than one data set, we send, it helps you, like Ciphertext will help send those pre-processing components to operate remotely, encrypt the tensors that represent the words, and then start the encrypted federated training. And of course, Ciphertext also, one major functionality that we need to enable is once you are happy with what you did, like the pre-processing pipeline, the tokenizer configuration is set up, and the parsers, the taggers, all the components that manipulate the text and transform it. And then the trained model or models, we can have multiple ones. Once we are happy with that, we need to deploy it, to make it available somewhere. So here I show you deployment. So we put this pipeline somewhere on the company's server or on servers that host these models and make it available for inference. So later, if a new worker or a new person, actually data owner, have a string and wants to use that deployed model, can actually do it. So Ciphertext will also help you after the model is deployed. If you search for it, and when I'm talking about search here, I'm talking about searching on PyGrid, which is the library or the framework or the network infrastructure also developed at OpenMined that connects between nodes or machines. If you want to process your own string, which is private to you, Ciphertext will know which component to send and also will know to protect the model itself. So if the company does not want to share the model, we can still do remote inference. So once pre-processing is done, encryption is done, and then you will get your results, encrypted predictions actually to your machine, and then your machine will decrypt it. So this tutorial is actually, and I'm going to explain very fast, like with these diagrams, and then I'm going to show you a notebook how things work actually. So I'm going, let me go to that. So I'm going to talk about a use case and show it using a Jupyter notebook. And yeah, so the first step, or the problem actually that we are going to treat is that you have different workers, two workers, Bob and Alice, two data owners. They have two data sets. They are the IMDb review data sets, but we consider that they are private. We don't have the right to see those reviews. And because in deep learning, we always prefer to have bigger data sets to create better models, we want to train on both data sets at the same time. So we cannot actually just take the data set and merge them because they are private. So we cannot move them actually from their machines. And at the same time, actually, the model we are creating, we cannot send it because it is private to us as data scientists. So what we need actually is to create the embeddings, as I showed you, into tensors and encrypt them. So I will show you this in diagram. So the first thing we are going to do, I'm going to show how to create a pipeline first of pre-processing, so tokenizer with vocabulary and some pre-processing components that we will see as taggers, and to also create a classifier with PySift. So here's what I'm explaining. Then you have Alice and Bob as, sorry, I think this is in the way. Yeah. So you have Bob and Alice, they have data sets, and I'm going to show you how Ciphertext actually, once you just define this, like the sequence of components of your model, Ciphertext will then handle cloning this pipeline and sending clones, like 2 clones here, tokenizer, like the pre-processing pipeline or sub-pipeline to each data owner. This will all be done actually automatically, but as data scientists, you work as if you are working locally. And I will show you how to train. So the encrypted vectors are then pooled. They are pooled only when they are encrypted. So we are not pooling strings. We are pooling the encrypted document embeddings, and we are using that for encrypted training of the PySift model. Now, if you already watched my previous talks, maybe you are familiar with this use case and with these diagrams even. Now, what is the plus actually that I'm going to present to you is that with Ciphertext 0.1.0 we are releasing soon, once you're happy with your trained model, actually, you will be able to deploy it on PyGrid. So you are going to bundle all this pipeline, including the PySift model that you are going to train the PySift classifier, and put it on PyGrid. Let's say it's one of those pipelines. And once you deploy it, actually, you will be able to use it. So to use it for inference. And I will be showing you 2 scenarios for this inference. So as we can consider that the trained model is no more private. So Bob will, whenever they request inference for the string, they will have the whole thing on their machine, even the PySift. So it's different from this diagram. They will have, so Bob will have tokenizer, taggers, and PySift here because we can actually download the model. I will show you another scenario where the model is still private to the company and the string is private to Bob. And once we load a PyGrid deployed model, Ciphertext will know actually how to divide this pipeline into 2 sub-pipelines and do the inference in a remote way. So you will send the encrypted vectors, and then you will deliver the encrypted logits, let's say, and Bob will be able to decrypt them. So let me start showing you the tutorial, but just one idea that you need to keep in mind. This idea of sub-pipelines, which is when we divide the pipeline into parts, like different parts can go to different places. We call it sub-pipelines because I'm going to show this to you in the code. For instance, here in this previous slide, you saw that there's a sub-pipeline for pre-processing that does not include the model. And here also there's sub-pipeline that goes to Bob, and there's sub-pipeline that contains the PySift that stays where the model is deployed on the machine, on the company's machine. So let's go to the notebook. And if we have some time, I will be explaining to you some of the deploy mechanics, like how how the deployment works. It's a bit technical. It's not the main subject today, but if you have some question about this, I can go into this. And as I told you, anytime you can ask me questions now, and I will answer them as I'm giving this talk. If you prefer to leave your question to the end, also feel free to do that. I'm going to stop the share and now share the notebook. Okay, so here it is. And that's the notebook. So I hope you're seeing the notebook now. If you're not, please tell me in the chat. Okay, so let's go to the beginning. So this is Ciphertext 0.1.0. If you go to the Ciphertext repo on GitHub, you will see this not in the master branch for the moment. We are releasing this soon. We're correcting some bugs and some like important issues, but this is the Ciphertext, let's say, _0.1.0 if you want to clone it and play with it. And while you are playing with that release, please reach out to me or to any like lib_Ciphertext channel in Slack so we can provide support and debugging for you. So these are some imports. So now what I'm going to show you is how to tokenize and like use these simple components in Ciphertext. So we have the tokenizer. So we want to tokenize a string. So we first import Ciphertext and we import the tokenizer because we are starting to construct actually a pipeline. We are creating a pipeline and we will put components inside it. We need to import PySift because we are building on top of it. And I'm here creating some virtual workers. So here I'm doing this demo on virtual workers. Many of the functionality works for real workers too. Like there are some nodes we deployed on AWS. I'm going to show you this at the end. Not all the functionality is yet working for the real nodes. We have some like technical issues. We are working actively in this, and I invite you to work also with us on that. So here, those are some utility functions. I'm going to talk about this later. So here it begins. So first, I create a pipeline. I give it a name, Ciphertext PriCon2020. So it's like arbitrary name. And I create a tokenizer. And the tokenizer has some configurations. So I can tell the tokenizer to, for instance, if I have some exceptions for tokenization, I can, for instance, the word man-made, if I want tokenizer to know that these are two words for some reason, maybe for medical text analysis, we have some special cases we need to tokenize. We can do it. We can also leave it without any arguments. So it will take the default arguments. So here I just like show you that we can do it. It's not very important what like the exact configuration and passing. So I create this tokenizer object and then I call this the language object, which is very similar to Spacey if you're familiar with Spacey. So it's a language object and I set the tokenizer. And notice here I set also some access rules. So I say that my tokenizer is not private. It can go to any machine and operate remotely. Then I will define what like a component called a simple tagger. So actually each word in a string that I'm going to process, if it's an animal name, it will just tag it as animal. Why this is important? Because in some cases, we need to exclude some words actually when I process string. For instance, stop words or words that not interesting for a classification task. So the simple tagger help us do it. So here I'm just going to add to each token an attribute called isAnimal. And this is the list of animal I need to recognize. And this attribute will take the value true. or false, and it's not case sensitive. And I add it, add pipeline, add pipe. I give a name to my component, which is the animal tagger I defined here. And the access is the same. I allow you to go and operate remotely on whatever machine I want. Here I can give names. For instance, I can tell it you can operate only on Bob or only on Alice. Now my language model has some pipes. So it's tokenizer and animal tagger. And I will talk to you about this variable soon. And I deploy it. So NLP test deploy on which worker, like for instance, Charlie. And now it's ready for use. Now let's do some tokenization. So here, actually, this is an artificial step. Let's say we don't need it when we work with like real grid nodes. But here I'm just removing all the objects I stored in my machine, which is as if I'm like, I deployed the model, I turned off the machine, and I'm just like starting fresh. And I'm going to show you the Charlie where I deploy the model. Just look at this list. This is the object store. So I see that the tokenizer, the animal tagger, and the language model itself, they are deployed there. They exist there. And here I'm just showing you that on me, there's nothing. Like it's my machine as data scientist is empty. Now I call Ciphertext load and the name of this language model or the pipeline I just deployed. And Ciphertext will automatically search on all nodes it knows like Bob, Alice, Charlie, and all those nodes. And it will import the language model, the language object, sorry. And here I show you what are the objects now on my machine. I imported this language model. This is the object store of my machine. So it found it, it imported, and now I can start tokenization. So I define a string. Actually, this is a PySif string, but it can also be a normal string without like this string, like Python native string. And I just call my language object with parentheses with that text, and I have a doc object. And here, after I do that, actually, notice that my object store, the object store of my local machine, notice what's there. So it imported the tokenizer and the animal tagger. It imports it only when tokenization and pre-processing is needed. And because they have access, they have the asterisk access rule, so we can import them and do things locally. Now I'm just going to print each token in that doc with some of the attributes that Ciphertext gives us access to. So for instance, is it a punctuation character? Is it out of vocabulary? Is it stop word? And also our custom attribute, is it animal? Notice token is animal. And notice, well, here some animals are marked as true. Some punctuation characters are marked as true. Everything is out of vocabulary because, as you noticed, I had defined no vocabulary. So the tokenizer knows how to tokenize, but there's no defined vocabulary. It does not know about words. There's no predefined vocabulary. There's no embedding vectors that I associated to my vocabulary. There's nothing there. So just before moving to the use case, let me also show you how to tokenize a remote string. So in this example, I have a string as data scientist on my machine. Now, what happens if, as I showed you, the string is not on my machine, it's on Dan's machines, for instance. So I define a string, I simulate that I have a private string by sending it to Dan, and this is actually a string pointer now, but I can also call the same object on the string pointer, and I get doc pointer object. So as I showed you in the figures a few minutes ago, that I have this document, but because the document is private, I only have a pointer to it. And notice here, the object store of Dan, it imported also a copy of the tokenizer and the animal tagger. And now notice that my language model, it tells you for each place where I needed to tokenize. For instance, for strings on my machine or for string on Dan, it created sub pipelines. So this sub pipeline has the whole thing, the tokenizer and the animal tagger. It's not divided yet because everything can be imported. And this is just another version of showing the sub pipelines by like the component names. And actually, because this is a document pointer, I cannot see what are the tokens in it. So I do the tokenization and that's it. Actually, it's up to the data owner to discover what's like the results of my pre-processing. I cannot actually, it will issue an error if I try to access things inside. I think I have an example. Yeah, I will have an example where I show you I cannot access the contents. So now let's create another pipeline very quickly, but this time I will put a vocabulary in it and I will put embedding vectors that are already calculated and I take them from a Spacey model. So I create a new pipeline I call Spacey EN Core Web LG because it's actually made available by Spacey, but I have broke it down and put it on my machine and I reduced it. I don't use all of its components, only the token, only the vocab, sorry. So here I have some files on my machine, but soon actually, actually this model is deployed already on the real grid node that is available. You can actually access it now if you want. I will show you the port, or if I don't have time, of course, we can talk about this on Slack if you want to take the addresses and everything. So I take two data structures, so the list of vectors and another list that I call hashed row, so the hash of each word and which row in the vector matrix its vector is stored. Don't bother these printouts, it just shows how they look. I define my vocabulary, which is Ciphertext object. I put the vector and the hashed row, and I call set tokenizer, set vocab, and I give the access. So I added the vocab this time, and I deploy the same way I did a few minutes ago. And I just show you that on Charlie, we have our first language model deployed, and also this one, now with the vocabulary. And this one is the one we are going to use for training for our use case, because it has these word embeddings, so we can do encrypted training and everything. So again, I just remove everything from my local machine as if I deployed things and my computer is now empty and I'm ready to load things from outside. We don't need this for real nodes again, but just to make things clean. Actually, if I don't do it, it won't give an error, but just to prove that even if I start from, like, we're not cheating here, we are really importing pipelines from the remote worker. So the use case. So the first thing, we are going to use the IMDb review dataset. I'm not going to show you like all the details to download the dataset and everything. I will make this Jupyter notebook available. But the thing you need to know is that I'm simulating private datasets. So I'm creating the dataset locally and I'm sending parts of it to Bob and parts of it to Alice. And this is what I'm going to have locally. I'm going to have two lists, Python lists. And in this list, there are many dictionaries. And in each dictionary, there are two items. So review, which is a pointer to the real review on Bob or on Alice, and the label, which is a tensor, 0 or 1. They are hot encoded, actually, 0, 1, or 1, 0. And I only have pointers. So locally, I have these lists, but inside them, only pointers, because the real data is private. So I'm going to skip all of this and just show you the results. So here for train Bob, for instance, if I take an example from it, it will be a dictionary. It has two keys, review and label, and the review is a string pointer, as I just explained, and the label is a pointer tensor, 0, 1, or 1, 0. And their locations are on Bob. I have also trained Alice. Now, I'm going to create the pipeline that contains the tokenizer and some taggers. I'm actually going to tag stop words and words that are not polar. I mean, words that do not they are neutral in relation to sentiments. So if they have no sentiment to them, I'm going to exclude them because maybe they don't contribute to classifying text as like for sentiment. And then I'm going to train a classifier and I'm going to add it to this pipeline and deploy it. So let's start first by loading the Spacey pipeline. Why? Because I'm going to use its vocabulary and add it to the new pipeline. So I load it, I deployed a few minutes ago, now I load it, NLP Spacey, and see like I have something called states, which is the data associated, the configuration of each pipe component. So I have the tokenizer and the vocab in it. So I have them now locally. I just show you here that I can tokenize with that loaded model. So I'm going to skip because I already showed you. So NLP Spacey, a string, and like I can just tokenize as I showed you already. But yeah, one difference here that when I see the OOV, is it out of vocabulary? No, because I already loaded the vocabulary and deploy it, and now I'm pulling it, and the vocabulary is pulled with it, and actually my vocabulary knows all of these words. So this is just reassuring that I'm importing the model correctly. And I have also vectors. So if I take one token from the document, it has a vector embedding. So now let's start creating our sentiment classifier pipeline. So NLP sentiment equals Ciphertext create, Ciphertext sentiment. I call it Ciphertext sentiment. I create a tokenizer, default tokenizer, and I add it with access rules that are universal. I take this vocabulary from the Spacey pipeline and I add it to the sentiment pipeline. And pipe names, I have the tokenizer. The vocab is not considered as a pipe, so you don't show it here. It's something associated with the tokenizer actually. And you can see the vocab in the states variable of my sentiment library model. So now I'm constructing it little by little. So I have this sentiment pipeline, I have a tokenizer in it, which has vocabulary and word embeddings. Now let's create the simple taggers that tag stop words and tag polarity of words. So I import from Ciphertext a list of stop words we have built in. Actually, we borrowed it also from Spacey, which is actually the inspiration of the base of Ciphertext and its UI or API, sorry. I create a simple tagger. So remember, I created a simple tagger for animals a few minutes ago. Now it's for stop words, so true or not. And I call this pipe element or this tagger is stop. Sorry, the attribute that will be associated to tokens to describe if they are stop words, I call it is stop. And I create another tagger. So here I'm not going also in the details of this. I'm just creating a list of words that has some polarity. So for instance, awesome is considered polar, so it's positively polar. And like awful is negative polar. And like the, for instance, is not polar at all, so I'm just removing it. So I create this is polar tagger, true, polar, or not. And this is the list of polar tokens. And I add them to the sentiment pipeline. I add them here. And I give them access, universal access, polarity tagger and stop tagger. And notice there's just a dictionary here that's called excluded tokens. And I tell it actually that for the is stop attribute that is tagged or created by the stop tagger, exclude everything that has isstop true and exclude everything that is polar false. So everything is not polar, just exclude it, because, well, here is just creating the dictionary, but I'm going later to show you how to use this dictionary to tell actually Ciphertext to look at a document and see every token as tagged as stop or not polar, and not use it when creating the document embedding vector. So this is why I called exclude tokens. So let's go ahead and see next. So here I'm just showing you pipeline templates. So this means actually my pipeline, it has tokenizer now it has a stop tagger, it has a polarity tagger. I'm just showing you or I could have called pipe names as I showed you just earlier. Now we are starting the training. So this is, if you are familiar with PyTorch, this is typical PyTorch code. So I'm going to create a dataset object that I'm going to use in the data loader of PyTorch. So the most important method in this dataset is the part actually that will take that string pointer I take from the dataset. So here's my dataset, which is train Bob or train Alice. I take an element from it and I pass it through my language model, which will be NLP sentiment. I get a doc pointer, and through that doc pointer, I can call a method. I cannot access tokens as plain text. There are methods that protects the string, but still useful. For instance, get encrypted vector. So I use SMPC encryption. So these are the workers that I can use to handle that encryption. It's a detail in this talk, but just these actually 3 arguments, just configuration for encryption. Don't care about it now. And this is where I tell once, like while you are creating this document embeddings, exclude these tokens I told you about. And actually what's happening here, the pointer get encrypted vector or embedding. So the doc pointer is sending a signal to the document, which is on Bob's machine, the data owner machine, and tell it that create a vector, exclude these tokens, and create the document embedding, encrypt it, and give me the encrypted vector. So this is vector that is encrypted. I do the same with the label. I encrypt it too. And that's it. So this is the dataset object that will, I give it a string pointer to like a string from my dataset, and it knows how to operate the pre-processing pipeline I defined with taggers and tokenizers. It triggers that pipeline and get me the encrypted vector that I will use for training. So these are data, like I'm just instantiate one for training and one for validation. And here I'm starting the training, but first I'm like defining learning rate, batch size, number of epochs. I'm not going to take too much time for training. And data loaders. So in the data loaders here, I send the training set. So the training set is just like a combination of Bob and Alice's pointers, the batch size, etc. And also just notice here, when I define the dataset objects, I pass to them the pipeline I defined. And now I define my classifier, which is very simple classifier actually. It's just a fully connected layer. It takes, so it's a fully connected layer. I operate it, I get the logits, and then I apply ReLU to get the probabilities, but I'm not going actually to use the probabilities, only the logits. And I instantiate that classifier. So the number of input features is 300 because my embeddings that I put in my vocabulary, the spacing embeddings, they have 300 like coefficients. And I have two outputs, like negative or positive sentiment. And notice here, because the document embeddings are encrypted with SMPC, I also need to encrypt the parameters of the classifier. So I'm operating in an encrypted space. So I'm passing the same encryption configuration. So I'm encrypting the classifier. And the SGD optimizer, I'm defining one. And I'm calling fixed precision because actually the SMPC encryption operates not on floating point numbers, but it's on long format, like integer format. So once we want to do the update steps, we need the optimizer to operate in fixed precision space. Now we started the training. So here it's like typical PyTorch training cycle. So for some epochs and for each element in the train loader, zero the gradients with the optimizer, forward pass, compute the loss, which is not like the best loss to use for classification, but I use it because some functionalities at the time of writing this were not yet supported in the encryption mode in PySift. This can be actually updated because I think now they are supported, I'm almost sure, but it works like for our use case. I compute also the accuracy of my prediction. And yeah, there's of course the backward pass, the optimization step, and logging to TensorBoard, and same for the validation step. Now, I do the training. I'm just going to stop the share and show you actually the TensorBoard log. I just launched it a few hours ago. And we are going back then to the, so this is it. So I trained on I think 12,500 examples on Bob and same on Alice. So as if my data set is 25,000. So I reached like pretty decent performance. So like performance is not, of course, the topic, but I'm just showing you the process. And let me stop and go ahead with the notebook. Yes, so here there's an error because I just stopped the training because I didn't need to go to the end of the training. I had satisfactory performance. Now we trained our model. Now we want to deploy it and make it available for inference. So the classifier, actually, if you noticed, I'm going to show you this again, it inherits from PySift plan object. So this is an object that is actually like all code that we write here, actually, it can be bundled and sent remotely. So we need to put that plan in a Ciphertext object that is called single label classifier that I import here. So single label classifier, I give it the classifier that I encrypted, and it will handle everything like building the plan. It will handle decrypting the classifier before sending. It will do this. And if we want, like at the time of inference, if we want MPC, we can just precise this. And if we want to do like no need for encryption, we can also provide this. And of course, we need to tell it because it's single label classifier. Like what are the names, the textual names of the labels, negative and positive. Why? Because actually the classifier, it will take a document and it will classify it, and then it will set an attribute to that document with the class of that document. Like, is it negative sentiment or positive sentiment? So we need those textual descriptions. And notice here we have another object that we pass, an average doc encoder. So while we did training, I showed you that we called get encrypted vector, and the current implementation, when we call this, is just the average of all word embeddings. So here we are telling that the classifier also, it should, the way we encode the document is an average encoding. So for the future, we are going to implement more types of embeddings for documents. So we have this classifier object, and we add it to the pipeline the same way we added the simple dagger. So we add it, we give it a name, sentiment classifier, and in the first version, I consider that my classifier is not private, so I can allow it to go where the data is, so universal access, and I will show you below that if I restrict this, I will have a remote inference. So now I allow it to be downloaded to the data owner's machine. So NLP sentiment, pipeline names, so we have tokenizer, stop tagger, etc. Or like now it has the 4 elements, including the classifier. And well, the states are the same information kind of. They have all universal access. It means that when we divide them, we don't need to divide them into multiple sub-pipelines because they all can go to the same machine, so I can bundle them in the same pipeline. So I deploy it, sentiment deploy. I put it in on Dan's machine, and now look at Dan's machine. It has my sentiment, all the components of my sentiment. So this is related to how the deployment process works. And now I reset my machine as if I turned off my machine on again. And now I'm ready for inference. Now local inference. It means that, as I told you, the model is not private. Whenever I load it, so here load Ciphertext sentiment, I show you that it's loaded. Well, here it just shows that it's loaded and it's downloaded to me, to my machine. Now I tokenize, or I operate this whole pipeline on that string. This is a really good movie. Watch it as soon as possible. I have the doc. It's on my machine. It's not private because the string is mine. It's on my machine. So here I call Ciphertext sentiment classifier. So actually the pipeline gives a custom attribute to the document that is in concatenation between the name of the pipeline and the name of the classifier or the task, sentiment classifier, and it's positive. And if I just peer into, look into the tokens, so some of them are marked as stop words, some are not, all of them are not polar. So just to show you that taggers work. And this movie is awful, do not watch it. So another string, negative, and here we have for instance, awful is marked as true, it's polar. Yeah, so, and this is actually now I'm trying to classify a remote string. So I send it to Alice and I operate the pipeline on it and try to see what is the label, and doc pointer has no attribute because it's a doc pointer. I do not have the right to see what is classified, like the result, but it's there. You need to believe me on this, but like for later versions, we will have the opportunity to be in debugging mode and to be able to peer into this. For the moment, we protect privacy. We don't allow it to be seen because it's a doc pointer. And just I show you here what happened. So the pipeline. So what are the pipeline that I created? So when I tokenize a string on my machine, the whole pipeline was imported until the sentiment classifier. It was downloaded. The classifier is downloaded. When I I tokenize something on Alice's machine, same happened actually. I have only one sub-pipeline for Alice. So the whole sub-pipelines is on Alice. So it includes the sentiment classifier. it was not cut into two. Now I'm going to show another example, the exact same, I'm recreating the same pipeline, so tokenizer, vocab, stop tagger, and I'm adding the classifier, but the access of the classifier is only on Dan. It means that only the machine where it is deployed, this classifier has the right to be. And if we need inference of a machine that is on Alice, the classifier cannot go with the whole pipeline as what we saw just above. It stays on Dan's machine and it operates remotely. So we deploy this new sentiment with a new permission, this pipeline with a new permission. And I'll show you that on Dan we have like Ciphertext sentiment and Ciphertext sentiment 2. So Ciphertext sentiment 2 is the one with this different permission. Now I load it. And so remember, it is deployed on Dan, and now I'm creating a string. I'm sending it to Bob as if it's a string that is private to Bob. And I'm running the pipeline on it. So I'm getting this doc pointer. And I'm running another one on Alice. I'm getting the doc pointer. Remember, I cannot see if they are classified correctly, but they have like, there is an attribute that is added. But what I'm going to show you here, that if I print the pipeline just to see how pipelines, sub-pipelines were divided, it tells you that, well, let me show you this. It's the same thing, but it has more details. So sub-pipeline templates, I call it. So when I tokenize a string that is on Alice, so for each one, I have two sub-pipelines. So the first sub-pipeline, which went really to Alice, downloaded to Alice, is the tokenizer, stop tagger, and the polarity tagger. These are pre-processing components. They have access as asterisk, so they can be downloaded. But the classifier stayed on Dan, and it operated actually remotely. And same for Bob. Like tokenizer, stop tagger, polarity tagger, they went to Bob, but the sentiment classifier stayed on Dan. So this is what I want to show you actually. Where to go from here? Of course, we have like a bit of work in order to make things working for real grid nodes. Like the big chunk of work is already done. Of course, we need, now we need real data sets to live on those nodes, to operate on them, to start to explore what are the real formats of data set that we need to work on, not like simulate things. And also when we deliver a document and to the data owner, how to consume it. So in real production settings. And of course we need to expand the Ciphertext model zoo. So we have single label classifier, we need multiple label classifier, we need translation components, etc. So let me share. By the way, if you have any question, you can start asking your questions now. So because the core presentation is finished, but I'm going to at the same time share some slides to you about some stuff I need to share with you. Yeah. So how you can help? So if you wish actually to join the team, let me share up. I just need to find, yeah, that's it. Yeah. So of course we need to do some work on the current release. So the core functionality, as you saw, is functional, but we need, of course, some like testing, debugging, and for future releases. So now we are using deployed pipeline for inference. Later, we want to use it for also be able to fine-tune it remotely, so do federated training, and for like more remotely, like remote goals is to start Ciphertext for mobile when we have like limited capacity. And of course, if you have like, you can think of papers in the privacy preserving NLP sphere, you want to implement it, play with it in Ciphertext and make it available as pipeline to other people on our real nodes, and of course, like real world scenarios. So you can, the repo name is Ciphertext, so you can go and play with it and ask for support on lib_Ciphertext channel on Slack. And if you want to apply to the team, placements.openmind.org. And if you are a researcher or you have a company, we are open to have a partnership so we can actually test this functionality on a real use case where we can really appreciate, as I said, like when we have a real data set and when we need to deliver a real result, how to consume it, how like to enlarge or expand this pipeline. So I think I have a question here. Oh, I have a thank you. So thank you a lot for thanking me. I have actually 4 minutes left. So if you have questions, feel free. And at the same time, I'm going to show you that the real nodes actually. So let me stop the share and share again. So the real nodes and their addresses, they're still like, sometimes we take them down and like recreate them, but we can, like if you have the time, you can start already playing with them. So it's the same, kind of the same notebook actually, but the workers are real nodes. So they are on AWS, Alice, Dan, Charlie, and Bob. And what we can do, well, now you're familiar. So now if you search for a model, if you now can like download the Ciphertext, you can find this model already deployed. So we do a search on PyGrid, Spacey and Core. So you see it on Alice, actually, it's already there. And if we list what's there exactly, so you see it has only tokenizer and vocab. So this is the model I created locally in my notebook, but it's deployed. And we load it here from AWS and we use it for tokenization. Notice like here we show like it's not out of vocabulary, it means that we got this, the real thing. And here we just show you that we create pipeline, like we add simple tagger and everything, and we like play with it, we tokenize it, and then we deploy it. I think it's here, and we deploy it on Charlie, which is a real node. And I think, well, here it's Bob. I think I have a list for Charlie. Yeah, so we deploy it. I don't have a printout that it's deployed on Charlie, but I think now if you list if you download Ciphertext and connect to those nodes, let me give you again the links. You should find them. And actually what we need, so the pipeline I showed you for sentiment analysis, we need to deploy it to. We still have like a few bugs because we are working on the new PySwift and Ciphertext version. So just a few bugs. I invite you to collaborate also with us to solve them. But in a few weeks, I hope that you'll be able to use Ciphertext on the real PyGrid. So thank you very much. I hope it was interesting for you and that you enjoyed my talk. And we have 2 minutes left. If you have any questions, you will be welcome. So let me. So this talk will be later released on OpenMind's YouTube channel. So you will be able to use it, as I mentioned earlier, for your reference to see how I implemented the whole thing. And I will also make this tutorial available, and very soon the real grid nodes available. So thank you very much for your listening. I was really glad that you joined this talk, and I hope to see you soon on Slack or on GitHub. Thank you.